Okay, guys, we are looking for, in this your turn one, we're looking for the arc length, not to measure the arc. Like the measure of this arc would be 120 degrees, but we're looking for the length. Okay, so now the length of that arc was going to be a part of the whole circumference. So I can say, let's call that length L. The part to the whole would be L to the complete circumference. A lot of you are totally forgetting the circumference formula, 2 pi r, which is also pi times d. Okay, if you forget that, write it down somewhere. You guys got to memorize these, okay? You've been dealing with these for too long. So the arc length to the part of the circumference would be 2 pi times 9, right? We're not given any units there. So part to the whole. And what can I use for the part that will help me? Well, I'm going to use the angle. The angle of the sector is 120 degrees to the whole circle is 360 degrees. The degrees cancel, which is good, and the 120 over 360 is 1/3. So really I have L over 18 pi is equal to 1 over 3. I can easily solve that by multiplying by 18 pi on both sides and get 6 pi. Okay, you can leave your answer like that because we're not told to estimate it to anything. If it says estimate to the nearest hundredth or tenth, you would plug in pi in your calculator, multiply by 6. Okay, this one's a little bit different. Number 2, we use a different color. This one, we are given the arc length this time. We haven't had any problem where we're given the arc length, have we? I don't think so. We've always had to find the arc length. So this is interesting. Muy interesante. So 3.93 is the arc length. Now, we know if that's something we're given, we know we have to use that in an equation, right? You can't just be given some information and never use it. So I'm going to assume that I'm going to use 3.93 as the arc length, but that's part of the entire circumference. So I need to do part to the whole, right? In this case, I'm doing 3.93, which is the arc length, to the whole circle's circumference, which is 2 pi r. So it's 2 pi times 5. And we want to find the area of the shaded sector. Okay, so we did a part to the whole with the arc length. We can do a part to the whole with the areas, right? We can do a part to the whole with the areas on the other side. Remember what I did back here was I told you we could use any two parts of this equation, right? You can only use in one equation at a time, but I can use this is equal to this. I can use this one is equal to that one, right? I can use this one is equal to that one. And on this one, this is the first one where we've had to actually compare those two on the right side. Okay, we did the length of the arc length divided by the circumference. We're going to use area of the sector compared to area of the circle. So let's see what happens. We've got to do that because we're looking for the area of the sector. So I'm going to do area of the sector compared to, that's part, compared to the whole area of the circle. Area of the circle is pi r squared. So pi times 5 squared. Okay. You can multiply that out if you want. I'm not going to bother to multiply it out yet because I'm seeing my mind is racing. I'm seeing some beauty in mathematics that things are going to cancel out right after I cross multiply. So let's cross multiply here. We're going to take this times this equals this times this. So area, which is what I want, times 2 pi times 5 is equal to 3.93 times pi 5 squared, which is 5 times 5. But I'm going to solve that by dividing by that other stuff, right? I'm looking for area, so I want to get rid of this stuff. 2 pi times 5. I'm going to divide by 2 pi times 5. And look what happens. We get a 5 that cancels out. That's nice. We get a pi that cancels out. That's beautiful. We're starting to get some tingles, right? The math is beautiful. I got 3.93 times 5, all divided by 2. That's not so beautiful. But let me see if I can do that in my head. Can I do that in my head? Ugh, it's ugly. 3.93 times 5 is a lot like dividing by 2, right? And then multiplying by 10. So 3930. 3930 divided by 2. And then I'm going to divide by 2 again. So I can divide that by 4. What is that? That's almost 10. That's 9, 36, 3, 33. 4 into 33 is 8 with a remainder of 1, 10. 4 into 10 is 2.5. I just did that in my head. I don't know if it's right. So I'm going to run over and grab my calculator. Unlike you guys, I don't have it in my sock and my man's here. Got my calculator in my drawer over here. Not my drawers. Don't misconstrue my words. 3.93 times 5 equals 19 point something. I'm going to divide that by 2. 9.825. Look at me. Woohoo! That one is area, so we're not given any units here, so we're going to write units squared. I should have actually written, where should I have written units? This was arc length, that was in units. This was units. Those units canceled, but then I had 5 units times 5 units, right? So it was units times units, give me units squared. Units should always cancel out the way we think they should cancel out and give us the answer we think we should get as far as area being in square units and length being in linear units, okay? That's it, folks. I hope that helps you. You want to be able to use this part to the whole, right? You need to either use the central angle. Let's go over this again. The central angle divided by 360 as one ratio, or you can use area of sector compared to area of the whole circle, or you can use arc length compared to the whole circumference. You can only use 2 of those ratios at a time, set them equal to each other, and then usually cross multiply. Sometimes it's easier where you can just multiply the bottom of something being divided to solve for it. Okay, that's it. Hope it helps.